Hello, my name is Adam. In this video, we are going to learn how to make Bomberman in Unity. Bomberman is a video game franchise originally released in Japan in July 1983. Bomberman gameplay involves strategically placing down bombs, which explode in multiple directions after a certain amount of time in order to destroy obstacles and kill enemies and other players. This tutorial focuses on implementing tile maps, sprite animations, and even local multiplayer. This was the most fun tutorial I've made so far because there's so many different ways you can customize the game, come up with unique game modes, and build your own stages. If you need help at any point in the tutorial, feel free to join our Discord community where we can offer direct help. There is a link in the description of the video. Please consider subscribing to the channel to support the amount of effort it takes to create a video like this one. It would mean a lot to me and it helps drive the growth of my channel. Thank you. Enjoy the video. All right, let's start by creating a new project using the Unity Hub. In the top right corner, I'm going to choose New Project. At the very top here, we can select which version of Unity you want to use, depending on which ones you have installed. I'll be using Unity 2020.3 for this tutorial, which is currently the latest long-term support version. But feel free to use whichever version for this game. It doesn't really matter too much for this tutorial. I'm also going to choose the 2D template here since this is going to be a 2D game and we need to utilize some of Unity's 2D tile map features. Finally, on the right here, we can name our project whatever you want and choose wherever you'd like to save the project. From there, we can create it, and this might take a minute to initialize, so we'll pick it back up as soon as it finishes. Before doing anything, I'm going to import a bunch of sprites that we're going to use throughout our project. If you want to use the exact same sprites that I'm going to be using, then you can download the whole project from GitHub. There's going to be a link in the description of the video. Upon clicking that link, it'll take you to the GitHub page here, where you can find the full project and you can download this. So if we can click this download link here, and then you'll have to unzip this file, or this folder, I should say. We can unzip this. And then within here, you can find all the assets that I'll be using. There's this sprites folder at the kind of root level here, which is just all the Photoshop files. So if you want to go back and edit some of these sprites, feel free. But we actually want to go into assets and then sprites. And this has all the PNG files, all the actual images that we can import into our project. And certainly feel free to use your own custom sprites. I definitely would actually encourage you to use your own sprites. But if you want to follow along with the exact same sprites I'll be using, you can download the project as I just showed you. And we can now just drag these files into our project here. I'm going to select all of them, drag them in. And I'm also going to create a new folder just to keep everything organized. So let's go ahead and right click, create folder. I'm going to call this sprites. Let's go ahead and drag all of these assets into there. And now we also need to change some of the import settings on these sprites. So if you click on any of them on the right here in our inspector, you can see various settings on these. And I'm going to select all of these sprites because we're going to change the same settings for all of them. First, I'm going to set the pixels per unit to 16. Now this value is unique to the sprites that I'm using. It could be different if you create your own custom sprites, but all of these are designed around usually 16 by 16 pixels. So what that means is when we bring this sprite into our game or into our world, 16 pixels will be equal to 1 unit in our world space. So it's just going to help us get the right sense of scale between all of our objects. But the actual value doesn't necessarily matter, but all of these assets are sort of designed around 16 by 16, 16 by 32, something like that. So 16 here will make everything be kind of normalized within our world with a unit of 1. Finally, I'm going to also change the filter mode from bilinear to point. This is going to get rid of filtering as it says no filter, which is important if you want to maintain that pixel graphic style, because with filtering, it's going to smooth out some of the images, which is going to make you lose kind of that pixel graphic style. So if you're using pixel graphics, usually you want to change this to point. That's really all we need to change. Potentially I could change the compression here to maybe none, since these are already really low. They're small file sizes to begin with, so if I want to maximize the quality of the images, I can just turn off compression, but it doesn't really matter too much. We can go ahead and apply all those changes. Once again, I selected all of them and changed all of them at once. It'd be a lot quicker. Now we still got to do one other thing, which is that some of these assets here are designed to be sprite sheets. You can see a lot of these have like multiple sprites contained within this single image. That's because we are going to splice those out and then we'll use those to create animations later on. So we can take this one image and actually splice it out into multiple different sprites. So let's go ahead and do that. First though, let's select all of the assets in here that are intended to be sort of sprite sheets. So it's going to be most of them except for some of these kind of square blocks here. So these block, brick, ground, and then these items are all just single images, but everything else is meant to be a sprite sheet. I'm going to select all of these. And for all of these ones, I need to change the sprite mode from single to multiple, meaning it's going to generate multiple sprites for this image or for this asset. So we can apply that change. That's good. And now we can go in here. We'll kind of have to do this one by one, but it'll be pretty quick. We can go to Sprite Editor. This will open up our Sprite Editor here, where we can now split this image into multiple sprites. So in the top here, we can go to Slice. And this option, you can only go to this Slice dropdown if you've changed that sprite mode to multiple. That's why it's really important to set that. Otherwise, you will not be able to access this menu here. And in this case, I'm going to change these to grid by cell count because I know there's all of these are perfectly spaced out. So I can just specify, like in this case, there's 4 columns in 1 row. And I'm also going to do keep empty recs. And I can slice, and you can see kind of how it creates, slices out into 4 different segments here. And then when I click slice and then apply, now I have 4 individual sprites. So if I close this, I can expand this and I can see each of the individual sprites within there. We're going to do that for all of these, and we'll go through this quick. Open this up, slice, change how many columns there are. 1, 2, 3, 4, 5, 6, 7. Change this to 7. There's 1 row. Now this is where the keep empty recs is important because this last one is intentionally meant to be empty for the animation of this brick. So without this, it would just ignore that one. But in this case, I actually want that to be there. So I'm going to make sure that keep empty recs is selected. Slice that out, apply it, good to go. We'll keep doing this for all of them. 1, 2, 3, 4, 5, 6, 7, 8 on this one. So we change this to 8, slice, apply, go to the next one. This one also has 8, so we can just slice, apply. And we'll go to the next one. Slice, apply. And then let's go to our character here. So there's 1, 2, 3, 4, 5, 6 in this case. So let's change this to 6. Slice, apply. And let's do all these other ones of the same one. Slice, apply. Here we have just different variations of the character, different colors, since there can be multiple characters, multiple players in this game. So there's just variations in their colors. Slice, apply. And then finally, let's do these big ones here. So now these ones need 4 columns, but there's also 4 rows. So we can slice that out, apply that. Same thing for these others. Slice, 4 columns, 4 rows, apply. Slice, apply. And finally, one more here. Slice, apply. There we go. And once again, I can expand any one of these now, and I should be able to see all of the individual sprites sliced out. So that looks good. Cool. So that is it in terms of importing our sprites. All right, next up, we can create our tile map for our scene. And actually, real quick before we change or create our tile map, I'm just going to change the background color here on my camera. So we select the camera here in our hierarchy. Hierarchy displays all of the game objects in our scene. And in the inspector, we can see all the properties and components on that game object. So here on the camera component, where I'm just going to change the background color to black. Obviously, feel free to customize that how you want. And actually, I'm going to do one other thing, which is just simply rename my scene here from sample scene to Bomberman. Not strictly needed, but just to keep everything organized here. Alright, so let's create our tile map for our stage. If I right click on our hierarchy, we can create a new object. And I can go to 2D object, tile map, and I'm going to do a rectangular tile map in this case. I'm going to call it, we're actually going to have 2 tile maps. We're going to have 1 tile map for all the indestructible objects. And then we're going to have a second tile map for all the destructible objects. So I'm going to call this one indestructible. Indestructible or destructibles. That's good. And if we go to our scene view, let's just switch from our game view to our scene view. You should see this button here called Open Tile Palette. So in order to start drawing tiles onto our tile map, we need to create a palette essentially. And to create our palette, we just need to drag in certain sprites in here and we'll create new tile assets for those. So we really need 4 tiles in our case, which are block, brick, ground, and ground shadow. So I can select those 4 sprites, and is that all we need? Yeah, I think that's all we need. And I can drag those into, oh, actually first I need to create a new palette. I'll just call this tiles. Create this. It'll ask us where we want to save this asset. I'm actually going to go back to assets folder here. I'm going to create a new folder called tiles. I want to save it inside there. Feel free to save it wherever you like. So we've got our tile palette here. It's empty, but now I can drag those 4 sprites into there. It's going to generate a new tile asset for each one. So once again, I'm going to also save these in our tiles folder. And there we can see our 4 tiles. If we go to our tiles folder here, you can see now there's an asset for each one of those sprites. And actually, we do need to change a few settings on these tiles too. So if we select any of these, you can see which sprite is assigned to the tile. We can change the tint color, the collider type. So the collider type is actually what we want to change here, where our block and our brick do need colliders, because you need to be able to run into those, or I guess not run into those. For our ground though, you're going to be standing on top of the ground, so we don't want a collider on our ground, so we can disable those. We can just set this to none, and those are good. Let's go ahead and open up our tile palette again, and now we can literally just start drawing our tile map. We can choose, if we go to the brush here, and we can then choose which one we want to draw, and we can just start drawing it, which is really cool. And you can erase things as you need to, and so on. And you can just change which one you're drawing, and so on. So you can just play around and construct any kind of stage you want. You know, feel free. This is the point where you can just get really creative and make any kind of stage. The way we're going to design or implement the mechanics of our game, it does not matter at all how you build your stage. It can be any shape, any size. It doesn't matter. It can be as big as you want, as small as you want. I'm just going to follow kind of a very standard pattern. I'm going to build one of the stages that's in the original game. So mine's going to be pretty uniform, but once again, feel free to customize it however you want. Okay, so let's see. I have to count this out. I think there's 1, 2, 3, 4, 6 by 5. So let's just start. Might need to space this out again, but 4, 5, and 6. And then there's 6 by 5, right? Yeah, so we got, oops, let's delete that. Keep going here. Okay, so that's our inner boundaries. Now I want to, before I do the outer boundary, I want to make this centered around our camera. You can see the kind of center point of our camera is right there. So I'm going to actually space this out so it's more centered. Yeah, that looks good. Okay, and then let's do our outer boundary here, which is just going to cover the whole thing. There we go. Perfect. And then finally, let's draw some grass in the middle here. All right, it's almost there. Keep going. Once again, feel free to just completely customize this however you want. I accidentally deleted some. Let's add those back. And I do have a little shadow here, so we can add like a shadow just to give a little bit more polish to our stage here. You know, once again, not strictly needed, but just adds a little bit of extra detail. Oops, wrong one. Okay, let's add that back. Is that it? Did I get everything? I think so. Looks good. Perfect. So we got our stage. That looks great. There's our Indestructibles. Now, if we go to our game view, you can see it doesn't fit on the screen very well. And that's because we need to sort of adjust our camera a little bit. So you can see it in the scene view, this white outline is the kind of the view of the camera, and we can see the preview down there. So what I'm going to do is I'm going to effectively zoom the camera out by changing the size here. If I go small, it's essentially making, that size of where our camera can see much smaller, which in a sense makes it feel like we're more zoomed in. So I'm actually going to make this bigger. I'm going to specifically do 7.5. If we do 6.5, it'll perfectly cover from edge to edge. I still need to offset our tile map, but 6.5 will perfectly cover. But I'm going to just do 7.5, just give it a little bit of extra space on the top and bottom. That should be good. And I'm going to offset our grid here. This grid, just so it's more aligned. So I need to offset this by half a unit in each axis. 0.5 in the X, 0.5 in the Y. And now it should be centered. Yeah, everything looks perfectly centered. There we go. Yeah, it looks perfect. Yeah, so once again, feel free to customize this. You can kind of zoom in or out however you want. 6.5, it's going to perfectly line up to the top and bottom, but I'm going to do 7.5 personally. That looks good. So that's all great. Now I'm actually going to create one other tile map, which is going to be for our bricks here that we'll lay out, and our bricks will be able to be destroyed. And so I'm going to right click our grid, 2D object tile map, and we're going to call this one Destructibles. And we can now open the tile palette window. We need to make sure we change the active tile map. So right now it's selected Destructibles, which is what I want, but make sure you're not drawing them on the wrong tile map. I'm going to go to Destructibles. I'm going to select my bricks here. I'm going to fill in all of these spaces. Oh, and this looks a little bit bugged, but that's okay. So we need here. Oh yeah, what is going? Oh, is this? Oh, the X and Y got set to negative 0.5. So set those back to 0. That got messed up. Let's open that up again. Make sure this is Destructibles. Select our brick. Yeah, we can go ahead and fill these in. I'm just designing mine based on the original game. Bear with me here. All right, I'm looking at my other monitor to see how this is laid out. Once again, feel free to fully customize this. It doesn't actually matter how it's set up. You can get as creative as you want with it. Those two there. There. Oh, this one's wrong actually. And then it should be here. Okay, almost done, almost there. All of those. This one right here is covered. Just trying to do it exactly how the original game was. I think that's correct. I guess it doesn't have to be perfect. It doesn't really matter for the sake of the tutorial here. There you go. I think that's correct to how the original game was. I'm missing these two. Yeah, that looks good. So we got the four corners. That's where the players will spawn. There's a few little gaps here and there. That looks good. Once again, it doesn't actually matter for the sake of the tutorial, but that looks good for now. So we can see all the bricks there. And we can switch back and forth between these two. And because we put those on a separate tile map, I can just hide those as if I need to. Or I can turn on and off the tile map. I guess that doesn't work, but yeah, just turning on and off the whole game object. Now, one thing that could be important is making sure that these destructible ones are sitting on top of the other ones. So we can go to our tile map renderer and set the order and layer. So if our indestructibles is 0, we're going to change this one to 1. That's going to guarantee that the bricks here will always be on top of the rest of it. So that might be important. And finally, the last thing we need to do is add a tile map collider to both of these objects. So we're going to to Indestructibles. We're going to search for Tilemap Collider here, 2D. And that's all we need to do. We don't have to change any settings. And same thing on our other one here. So now, like if I were to play the game, it's going to generate tile maps or it's going to generate colliders for all of those tiles that we marked as having a collider. So we can see, for example, let me turn that off for now. On our Indestructibles, we can see this green outline. It's going to be hard to see, but this green outline is representing all the tiles that have a collider on it. So the grass doesn't, but some of these, all these bricks in between do. Same thing on our other layer here where we have kind of this green outline of all those bricks. So that's going to be important as we start implementing movement. So you can actually walk into the bricks and not walk over them. But that is good for now. That is our tile map setup. All right, now let's go ahead and set up our player object so then we can begin writing our first scripts for player movement. And actually, real quick, I'm going to just rename grid here to stage. Doesn't really matter, but cool. All right, so I'm going to right click in our hierarchy. I'm going to create a brand new object, an empty object. Here, I'm going to call this player. I'm going to reset the transform here. It'll just reset all the values back to their defaults. So right click or go to this 3-dot menu. We can go to reset. And we need a few different components on our player. So first we need a rigid body, 2D, because it's a 2D game. And the rigid body turns this into a physics object, which is going to allow us to handle movement and collision. For now, on our rigid body, let's change some of these properties. So we're going to get rid of drag, angular drag, and we're going to get rid of gravity. We don't actually want gravity to impact us for this particular game. I can even go to constraints here and freeze the rotation because the character or the player is not going to rotate in any way. So we can freeze that so it doesn't accidentally rotate. And for the collision detection, I'm going to change this to continuous. This isn't strictly needed, but this will just improve the collision detection for our player. And for the player, the collision detection is pretty important. So we want this to be as good as possible. Changing it to continuous does come with a performance increase or performance cost. But since it's just going to be for the player and nothing else, this should be totally fine. Now I also need to add a collider to our player. So we can add a collider, and there's different kinds of colliders, just different shapes essentially. It's just defining the shape of the collision area. So there's like a box collider, there's a circle collider. In my case, I'm going to use a circle collider. And you can see here this green outline, once again, is representing the collider area. And we might adjust this, but first we need to get some sprites onto our player before we can adjust that a little bit. But for now, that's good. Now, as a child of this game object, I'm going to create more game objects that are parented to the player. That will be children of the player. And I'm going to do that for each of the kind of directions the player can face. Right? So we need a sprite renderer to render the sprite of the player. But there's different sets of sprites depending on the direction the player is moving. If they're moving up, down, left, or right, there's different sets of sprites. So the way we're going to implement this is actually going to have multiple sprite renderers, one for each direction. And then we can just turn on and off them as needed in our code, depending on the direction we're facing. So I'm going to right click our player and go to create empty. You'll see this is going to create a child of our player. It's nested here. And I'll just call this one up. I'll add a sprite renderer component. And we can assign our sprite here. So I'm going to go with the white player here, which is usually player 1 in Bomberman. We can expand this and we can choose which sprite we want from here. So for up, we're going to find this first one here, which is the idle pose. And now notice I can't see my player. It's hidden behind the bricks, and that's because of the order and layer. We're going to change the order and layer. And I'm going to set this to 5. Earlier we set our Indestructibles to 0, our Destructibles to 1, and then we're going to set this one to 5 because as we add other objects, we're going to use 2, 3, and 4 for other things. So I want to make sure the player is always at the very top. So I'm just going to set this to be the largest value. I think we're going to use bombs will be, I think, on 1, and explosions will be on 2, and items will be, or maybe items will be 1, bombs 2, explosions 3, or something like that. but we're going to adjust that, make sure the player is just always the highest here. So that looks good. And we can now go ahead and duplicate this. Actually, before we duplicate it, let's take a look at our player. So we select our player. You can see that circle collider we added. We actually want to offset the position of our player up a little bit, because right now it's putting the sprite sort of in the center of our, let me move this so the camera is not in the way. It's putting the sprite in the center, but we want it to be more like here. That way, based on, you know, if the player is standing right here, that's their collider, but then the sprite will be sort of offset. So for example, if we have the player positioned up here in the corner, this is where they will spawn. So they're going to spawn at -6, let's say, and 5, and these should be perfect whole numbers. That way they are aligning to a grid. We want everything aligned to this grid here. The -6, 5, for example, would be the spawn point. We can see the circle collider kind of perfectly fits within that grid there, that tile. And then we can offset the position of our sprite here, sprite renderer, to make sure it lines up with that. So really we just need to set it to be 0.5. And you can see it kind of puts it in the middle. Now with the sprites I use, we can maybe adjust it a little bit more. So I might want to make a slight offset to the right here. And I think in my case, I did 0. This is kind of a random number, but 0.0625. It doesn't really matter, but feel free to like adjust it just a little bit so it just visually looks centered. And then same thing here. I'm gonna offset that by the same amount. So yeah, 0.4375. So personally, that's what I like. Just visually, it feels to me the most centered within the circle here. But so feel free to kind of adjust that how you need to. But that looks good. And then as we move around, we'll stay within the grid, but our tile will be able to kind of overlap some of those other squares. All right, so we have our up one. We can just duplicate this. We can right click and duplicate, or we can do Control D or Command D. Duplicate this. I'll call this one down, and then we'll assign a different sprite. Let's find the down one. Let's find the idle one. It should be this one. No, it should be this one here. That looks good. We duplicate it again. We'll do left. So for left here, let's get the idle left. And we'll duplicate it one more time. We'll get right. We'll set this one. There we go. Now, right now, all 4 of them are kind of stacked on top of each other. So I'm going to turn off the up, left, and right. I'm going to keep down as the kind of default active one, because that's kind of the direction we're going to spawn facing. So just went and turned off the sprite renderers on up, left, and right. Kept the down one on. And so there's our player set up, kind of positioned in the corner. And that's good for now. All right, let's create our very first script for our player movement. So first, I'm going to create a new folder in our project panel down here. I'm going to call this scripts. And let's right click, create C# script. And I'm going to call this movement controller. And we can now drag this script onto our player object here into this empty space at the bottom. It'll add our script to it. So this script will now execute as part of our player here. You can go ahead and edit the script. And we can begin coding this. And let me turn this off. Okay. So for our movement controller here, we need to first get a reference to our rigid body, because it's through our rigid body that we're going to actually move our character. And we need to move our character through the rigid body, because the rigid body is what detects collision between other objects. So whenever you create a new script in Unity, it's going to create a class with the same name as the file, and it's going to inherit from mono behavior. That's all good. And it also adds a couple placeholder functions here that are just very commonly used, but personally I like to delete all these and kind of just start fresh. So first, let's define several different variables we're going to need for our movement here. So first, like I said, we're going to need a reference to our rigid body and rigid body 2D. And we're going to call this rigid body. And I like to make this reference here a public getter with a private setter. That way, if we have some other script who needs to access the rigid body on the player, they can do so. So it has a public getter with a private setter. And we can simply assign this value here in our awake function. So awake is called by Unity automatically the very first, or essentially right when this script is initialized. And this needs to be exactly spelled this way. It needs to be a capital A, not a lowercase a, otherwise it won't get called. Unity is very picky about it because this is one of the Unity's built-in functions. Here we can assign our rigid body. We can say rigid body equals get component. This is going to search on that same game object that our script is running. It's going to search for a component of whatever type we specify. So if I say get component rigid body 2D, it's going to search on this game object for a component of rigid body 2D. And if it finds it, it'll assign it to our variable here, is what we want. And now there is a little warning here just because of how my thing is set up. It says rigid body hides inherited member component.rigidbody. That's because in some of the base classes here, there's actually another property with this exact same name. It's actually an obsolete property from a very, very old version of Unity, but it's still technically within the code. And so it causes like a conflict in terms of the name. You can actually see it here and you can see it's marked as obsolete. It's deprecated. The warning won't actually cause any problems, but if we want to suppress that warning, we can simply rename this to just something else so it doesn't conflict with that name. Or if we intentionally want to keep that name, we can just add a new keyword on here. It doesn't really matter. It's not a big deal. At the very least, just call it something else if that warning is bothering you. We got a rigid body, great. What are some other variables we need for movement? Well, we need to track which direction we're moving. And so this is going to be a private variable. Well, it'll be a vector2, and we'll just call this direction. And I'm also going to initially assign this to be down, because that's, once again, the direction we spawn facing. So it'll be down will be our initial direction. We should also add a variable for speed, or how quick can we move. This one I'm going to make public, and I'm going to say defaulted to 5. And we can see in the editor, because I've made that public, it'll show up here on our movement controller, so I can just freely customize this. So now that I've declared the variable, I can change this in the editor and customize it however I need to. This is really convenient. Finally, we need some variables for input. And the reason, normally I don't create variables for the input like this, but because this is going to be a multiplayer game, we need to be able to change what those inputs are for each player. That way, you know, they're not, one person isn't controlling multiple players with the same set of controls. So I'm going to add some public key codes here. Key code will allow us to change which keys on the keyboard we use for our inputs. So I'm going to call one input up. And let's say I default this to maybe W. I can do key code input down will be default to S. Input left will be A. And key code input right will be D. And so once again, I made those public, so they'll show up here in our editor, and we can change these if we need to. So once later on, once we have multiple characters or multiple players, we'll just duplicate this whole player object, and we can just change these keys. So, you know, player 2 has maybe the arrow keys instead. All right, so that's enough now for variables. We can actually start to implement some of the logic. So let's add our update function. This is another built-in Unity function, so it needs to be spelled exactly correct. Make sure it has a capital U, not a lowercase u. This is going to get called every single frame the game is running. And this is usually the function where we check for input. So what we can do is say if input.get key, and there's a few variations. There's get key down, and get key up. Get key is going to check that some key is pressed every single frame. You're like, basically you're holding down the key. Get key down will only return true the first frame, or that single frame where it gets pressed down. And then get key up will return true the single frame when it gets released. But in our case, we want to be able to hold it down. So, you know, this, you don't want to have to continuously tap www just to move up. You want to just be able to hold that down. So we're going to do get key. We can say input up. And then we'll do some logic, but we'll come back to what we'll do inside here. So let's go ahead and add the rest of these here. So we'll do the same thing for the others. Get key, input down. We're going to do an else, right? You can only really move in one direction at a time. So we can check, hey, are you moving up? Else, are we moving down? Else, are we moving, let's say to the left? Get key, input left. Else, are we moving to the right? Input right. Beautiful. And then if you're not pressing anything, then you're basically not moving, and we'll do some code in there. So inside of each of these, we need to set the direction of our player, but we're going to add a new function for this. I'm going to have a function here called set direction. It doesn't need a return type. It can just be private. We're going to pass in the direction we want to set. So be a vector2 because our direction here is a vector2. I'm going to call this new direction, and we can assign direction equals new direction. And we're going to do some stuff in here later with sprites. So that'll be kind of the next section of the video, but for now, this is all we need. And so in each of these, we can set these. We can say set direction to be vector2.up. Then we can say set direction to be vector2.down. Set direction to be vector2.left, and set direction to be vector2.right. And then if you're not pressing any of those keys, we can set direction to be vector2.0. There you go. That's perfect. The function gets called. We update our direction. Once again, we're going to do some other logic in here as well, but for now, this is good. So that's checking input. Now we need to actually move the player by by accessing the rigid body and then changing the position based on this direction. When we are changing the rigid body or moving an object via the rigid body, we want to do that in a function called fixed update. Once again, another built-in Unity function, so make sure it is spelled exactly right, the same exact casing here. Fixed update is going to get called every single, essentially, physics update. This is usually used for physics. It runs on a fixed time interval. So update runs every single frame you're gaming. Every single frame your game is running. That means depending on the frame rate of your game, this might get called more or less often. We usually don't want to do physics within update because then your physics is going to be very variable based on your frame rate, which we don't want. We want the physics to be consistent. We usually do it in fixed updates since it runs at a consistent fixed time interval. So here we can get our current position by accessing our rigid body. So rigid body.position. We can then figure out like how much do we want to translate the character by. In other words, how much do we want to move the character? Call this translation. This is going to be whatever direction we're currently moving times the speed that we're moving at. And then we also want to do this over time. So we can say times time.fixed delta time. So this is the amount of time that has elapsed since the last time this was called. If you're doing time in update, you would use delta time, but since we're in fixed update, we use fixed delta time. And now we can simply move our rigid body by saying rigid body.move position. We can take our current position plus that translation, and that will result in a new position. And so that's it in that regard. Let's go ahead and test this out. Go to our player here. Yep, everything's set. Speed is 5. We've got our inputs there. Let's go ahead and run this. And this looks good. I sort of am getting stuck. And that's because our collider here is kind of perfectly the size here. So I'm sort of getting stuck, which is a bit of a problem. But we can adjust that. So let's go ahead and make a couple minor adjustments. One thing we want to do is add a physics material to our rigid body here and to our collider to kind of reduce the amount of friction between collisions. So that way we can kind of smoothly move between our tiles. I'm going to actually create a new folder for this. I usually like to call this folder physics. And we can right click, create 2D, physics material 2D. And I'm going to call this no friction. You can see in the inspector, there's two properties, friction and bounciness. So I want to set the friction to 0. And we'll also definitely want to keep bounciness to 0. And we can assign this to our rigid body. And just to be safe, let's also assign it to our collider here. Now let's rerun and see if that helps smooth out some of those collisions. Yeah, now I can kind of freely move without me getting stuck on the walls. And the reason we used a circle collider instead of a box collider is because once again, it smooths out some of the transitions when you're kind of changing direction. It allows you to kind of go over these corners much more smoothly. Otherwise, with a box collider, you can kind of get stuck, which isn't good. The circle, it just kind of makes it just a lot smoother. But yeah, this looks perfect. Obviously, we're not changing directions because we haven't implemented that, but that will be our next goal. All right, let's work on getting the sprites fully set up and animated for our player. So first, I'm actually going to create a brand new script. So I'm going to right click, create C# script. I'm going to call this animated sprite renderer. Let's go ahead and open this up. So this is going to be a simple script to just animate our sprites, kind of loop through a cycle of sprites. And we're actually going to reuse the same script for a bunch of different objects in our game, not just for the player. We're going to use it for basically everything. So it's going to be just a really convenient script. It won't be very much code, but it's going to save a lot of time instead of setting up animations. There are other ways you can set up animations directly in Unity without needing to write code. Personally, I find that to be more tedious and more difficult than just writing a simple script that I can then reuse very easily. So in here, this is animated sprite render, so it implies that we need a reference to the sprite renderer component on our object. So I'm going to add a private reference to this sprite render, call it sprite render. The sprite render is where we can actually change the sprite, so that's why we need a reference to this. And we're going to assign this in a wake, just like we did for some of our other component references in our other script. Get component, sprite renderer. Now, when this behavior here, our animated sprite render, is enabled, we want to also enable our sprite render. And when this is disabled, we also want to disable our sprite render. So Unity has functions for this called onEnable and onDisable. Once again, these are built-in Unity functions, so the spelling, casing needs to be exactly the same, otherwise they won't get called. And so here we can say sprite render enabled is true, and sprite render enabled is false, just to kind of match. That way we can control everything through our class here, but it's going to kind of enable and disable the actual sprite render as needed. Now, when our sprite render starts, so there's a start function that's another built-in Unity function. This gets called the very first frame that this script runs on our object. It gets called one time, the very first frame it's enabled. And in here, we can essentially do our animation or invoke a function that's going to handle our animation. We actually need to first declare another function though. So let's create one more function. I'm just going to call this next frame. This is going to sort of advance to the next frame of our animation, which will then change the sprite and so on. So in our start, we can say invoke repeating. This is a convenient function Unity offers where we can invoke some function repeatedly over and over and over again, which is next frame. We can say name of next frame. We need to provide the name of the function we want to invoke. So this is one way to do that. Then we want to say how often does it repeat, or how long does it initially take before it gets called, and then how long thereafter in between every one. And so I'm just going to use the same variable for each, but we actually need to define what those variables are first. Let's create some variables here. I want to make these public. That way we can customize the value in the editor. And we will need to do that because different animations will have different animation times. This will be a float. I'm going to call it animation time. I'm going to default it to like 1/4 of a second. So what this means is every 1/4 of a second, it's going to advance to the next frame. So that means too that every 4 frames will be 1 second. Once again, this is just the default value. We'll be able to customize this in the editor per each object. And I'm passing that value in for each of these parameters here, time and repeat rate. Now we also need a variable to keep track of what is our current frame that we're on. So this will be like an index. So this will be an integer, and I'm gonna call this animation frame. We don't need to provide a default because it defaults to 0 just by itself. We also need some variables for our array of sprites. We can have an array here. So this is sprite, and then this tells it it's an array of sprites. We'll call this animation sprites. I also want to add a sprite to just be like our idle sprite. So if you don't want this to currently be animated, we can specify like an idle sprite. And finally, let's just add 2 other variables for should this animation be loop, like should it loop over and over again? And by default, this can be true because most of our animations will loop. And let's also add one other boolean to indicate if this animation is idle. So is it essentially currently animating or not? And that's where we can switch to the idle sprite if it's set to idle. I'm going to default this to true as well. Finally, in our function here, this is where we'll handle all the logic. So when we advance to the next frame, we should increment our frame. Then we need to say, now that we're changing the frame, we need to check, hey, do we need to loop back to the beginning? So if we told our animation to loop and our animation frame is greater than or equal to however many sprites there are in our array, so sprites.length, well, then that means we're beyond the bounds of our array. And so if we try to access the array at that index, it's going to cause an error. So we need to loop back to the very beginning. So we can set this back to 0. Finally, we can then set our sprite on our sprite render. And we're going to first check, are you idle? And if we're idle, we'll then set our sprite renderer, sprite renderer.sprite to be our idle sprite. Else, if we're not idle, then we will set our sprite renderer sprite to be our animation sprites, and then whichever frame we're currently on. We're accessing our array at that index here. And just to be safe, I'm going to actually say else if our animation frame is greater than or equal to 0 and our animation frame is less than animation sprites.length. This will just guarantee that we will never try to access this array out of bounds, which potentially could cause, if you access this array at an invalid index, you'll get an index out of bounds exception, which we don't want. So just to be safe, and that's it. So this is our full code for our animation. We're going to reuse this in so many different places, and there's really not much to it. All right, so let's set this up on our player. So if we go to our player, we're going to add that script to each of these 4 things. So we'll drag that on, and let's go ahead and set these different values here. So for our idle sprite, it's actually going to be the same sprite that we used or set initially. We can then set, there's 4 different sprites for our actual animation of you moving up. That's going to be 0, 1, 2, and 3. And I'm going to set the animation time to be I'm going to do 6 frames a second, so I can do 1 divided by 6. Feel free to, customize that depending on how quick you want your things to animate. It is looping, and initially it will be idle, but we're going to change that in our code. That's good. Same thing now, we can go, and since this is initially disabled, I'm going to initially disable this as well. Same thing, let's add our animated sprite renderer. We can set our idle sprite. This one is going to start at 4 here. Well, there are 4 animations for down. 1, 4, 5, 6, and 7 in my case. Same speed as the other one. And that's good to go. Go to our left now. This will be 8. And there's 4 different animations. So 8, 9, 10, and 11. Same speed. And let's disable that to match and go to our right. 12, Oops, 4 animations, 4 sprites in our animation. 12, 13, 14, and 15. Oops, 15. Same speed. Beautiful. Disable that initially. Great. Now let's go back to our movement controller and we can finish this up. So we need to get a reference to all of those. So we're going to add a public animated sprite renderer reference here. I'm going to call this sprite renderer up. And we're going to do that same thing. Sprite renderer down, sprite renderer left, sprite renderer right. And so this is where we're going to update our direction function here, where we're going to add another parameter or function to pass in which sprite renderer we want to essentially enable based on the direction. So we'll just call this sprite renderer. And so we will say for each of our sprite renderers, so if we're sprite renderer up, we're going to enable it if the sprite renderer that we're passing to our function is the sprite renderer up. And then same thing for the others. So down will get enabled if the one we pass in is the down one. Left is going to get enabled if the one we pass in is left. And right is going to get enabled if the one we pass in is right. And this will make it so if, let's say we pass in up, well, up will get enabled because it matches, but the others will all get disabled. So it's perfect. So it'll always guarantee one of them's enabled and the rest get disabled. Now we do need to track which of these sprite renderers is currently active for when we do our idle state or when you're not moving. So I'm going to add a private reference here and I'm going to call this active sprite renderer. That way we can pass this in when you're not moving. We still need to pass in which sprite renderer to go. So you're just going to do whichever one was essentially previously active. And so we'll assign active sprite renderer to be the sprite renderer. And on the active sprite renderer, we will say idle. The idle will only get set if our direction is 0. So if the direction is anything other than 0, then we are not idle. That's all we need for that. And finally, in each of these, you can see I have errors because I am not passing in the second parameter now. So when you go up, we want to pass in sprite renderer up. When we go down, we want to pass in sprite renderer down. And so on. Left is left and right is right. And then for 0, we're going to just pass in whichever one is currently active or previously active. We'll just continue to render that one for when you're not moving at all. All right, that should be good. Let's test this out. Oh, we need to assign these references here. So we'll see all these references show up. So let's go ahead and assign these. So up to up, down to down, left to left, and right to right. Let's go ahead and play this. Oh, so I got an error. So that's not good. Let's see what this error is about. Null. Oh, so it's because initially my active sprite renderer is null. And I'm not initially moving. So when we try to access it, it causes a problem. And that's because when we start, I should set active sprite renderer to be down, just to match everything else. Our initial direction is down and so on. So I'm going to set that initially to be the active one. Rerun this. This error should not happen this time. There we go. So I'm moving to the right. You can see our characters being animated. Let me maximize this. You can see our characters animating. Looks great. Moving left, animates. Moving down, animates. Moving up, animates. Beautiful. And you can see in our editor here, so these will kind of get, I'm moving up, so they're enabled. Once I move down, they get disabled, and then down, right? So it kind of switches between the different sprite renders depending on the direction I'm moving. And that all looks perfect. Nice. So there we go. We've got a moving animated character. Awesome. All right, next, let's start working on being able to place bombs. First, we need to create a prefab for our bomb. That way we can reinstantiate the same object over and over again. So let's go ahead and create a bomb. Let's right click in our hierarchy, create empty. I'm going to call this bomb. I'm going to reset the transform here. And let's add a few different components. So for one, we need a sprite renderer. And I can initially set the sprite to just be that first one in our animation. I'm going to change the order and layer, just like I did for some of these others. I want to make sure the bombs always are sitting on top of our stage. So let's just set this to, let's say 3. And you can see now it's sitting on top of everything, because otherwise it gets rendered behind things. We also need to add a rigid body 2D to our bomb here. This is only really needed so we can actually push the bombs around, which is fun. So you don't necessarily need this, but if you want to be able to like push the bombs and kind of move them, we need them to be rigid bodies so they can kind of get moved around based on the physics. And I'm going to turn off angular drag. I'm going to turn off gravity. I'm going to freeze the rotation, and we're all good there. All right, what else? We need a collider, and I'm going to use a circle collider for this, which makes sense because it's round in shape. Let's make sure that the collider lines up. So yeah, it's a little big, so I'm going to probably reduce the size of my collider here to kind of better fits the shape. So yeah, 0.35, I'm going to do 0.4. That looks pretty good. Feel free to adjust that to your liking. We are going to initially mark this as a trigger. So what this does is when something's a trigger, you won't physically collide with the object, but you can still detect when collision happens in code. This is important because when you drop a bomb, you're going to be dropping it right below you. So you and the bomb will be technically colliding with each other when you initially drop it. And if it's not a trigger, then when you drop the bomb, it's going to like push it out of you. It's going to like push it off to the side, which is going to be really weird. Or it's going to push the player, which is going to be weird. So initially we want it to be a trigger, and in our code, we're going to then change it to not be a trigger after the player has stepped off of it. Then once you collide with the bomb, or if you run into the bomb, it will have normal collision detection. You'll even push the bomb and so on. But yeah, initially it'll be marked as a trigger. And we also want an animated sprite renderer. So we're going to use that same component, that same script we just wrote for our player. We're going to reuse it here again. So for our idle sprite, that'll just be the first one in our sequence. There's 4 sprites, as you can see here. So we'll do 0, 1, 2, and 3. And for the animation time, we'll leave that how it is. There's 4 sprites. So essentially the bomb will cycle through the full animation every second. It is looping, and we don't need this to be idle because as soon as the bomb is placed, it starts animating and it never stops animating. So we don't need it to be idle. It'll just always be animating. And that's good there. So now we have our bomb. We can turn this into a prefab. Let me first create a new folder in our project. I'm going to call this prefabs. A prefab is basically a way to turn a game object into an asset so we can reuse it across our whole project. Or we can reference it in a script so we can reinstantiate an exact copy of this game object over and over and over again. So we can just simply drag this game object into our project panel and it turns it into a prefab. And once we've done that, we can now remove it from our scene. We don't need it in there anymore. And here we have our game object, same properties and everything, and we're good there. All right, so let's start writing our script for our bomb controller. So let's right click C# script, bomb controller. And we're going to add this script to our player as well. We're going to add this. We could have just made one script for both movement and bombs. Essentially, we could have just created like a player script. But this just helps separate the responsibilities of just the different responsibilities of the player, help organize the code a little bit more. That way we don't have one giant class that does a bunch of different things. Go ahead and edit this. And let's start writing our script here. So we're going to need to get a reference to that prefab we just created. That way we can instantiate the bomb over and over again. So I'm going to say public game object, and I'm going to call this bomb prefab. We also want to define a key code for our input, just like we did in our movement controller, because we're going to be able to change that key code based on if you're player 1, player 2, player 3, etc. We can add a key code here for, let's say, we'll just call this input key. And maybe by default, I'll do like spacebar or something. Cool. What else do we want? we should add some variables for how long does it take a bomb to explode. So you drop a bomb, how long does it take before it explodes? I'll maybe call this, and this will be a float. We'll maybe call this bomb fuse time. Maybe it'll be 3 seconds initially. We should also have a variable for how many bombs can the player drop at once. And this is actually later in the tutorial, we'll add like item power-ups or pickups. So it'll increase this number. So initially, let's say you can only start with 1 bomb, but then you can, if you get certain power-ups or pickups, you can then drop 2 bombs, 3 bombs, 4 bombs before you're out. And so since we're keeping track of how many bombs the player can drop, we also need to know how many bombs does the player have remaining. And this can just be a private variable because it's not something we need to change in the editor. These are all customizable values. We can change the editor, but this is just like state for our controller. So this can be private. I'll call this bombs remaining. And that's it for bombs. There will be other variables for explosions and things, but we're going to do that separately. We wanted to just get the bombs working for now. Let's go ahead and whenever our script starts, or we can do on enable, we should make sure we're set bombs remaining to be however many bombs, you know, because this will default to 0 with. So we don't want to say bombs remaining is 0 because then you won't be able to drop any. So we want to make sure we're setting bombs remaining to however many you start with. All right. In our update function, we can check for input just like we've done in our movement scripts. So we can say if input gets key down. Now this time I'm going to do get key down because I don't want to, you shouldn't like hold spacebar and like then you could just drop all your bombs all at once. We want to just press spacebar once and then it'll go. So we'll do get key down. We'll do input key here. And before we actually check for input, we want to make sure you have bombs remaining. If bombs remaining is 0, well, then you can't drop anymore. So we can just simply check if bombs remaining is greater than 0 and you've pressed your input key, then we can drop a bomb. Let's go ahead and create another function for placing a bomb. And we can call that here. Place bomb. Now this is where we're gonna do, this is slightly more advanced. This is probably gonna be the only slightly advanced topic of this tutorial. We're actually gonna use something called a coroutine, which is a special kind of function that allows you to suspend the execution of the function over time. Because we need to place a bomb and then we need to wait before it explodes, and then once it explodes we need to do some logic, and then the explosion will have a certain duration to it. And so we want to do a coroutine where we can execute some logic, pause the function, wait, then execute some more logic, and so on. So to create a coroutine, we actually need to import using system.collections. And we need to change the return type on this function to be IEnumerator, not to be confused with IEnumerable, IEnumerator. And then finally, we can start to implement our logic. And I'll show you what it means to actually suspend the execution of this. Oh, and instead of just simply calling the function, now we need to say start coroutine and then call our function. So that looks good. All right, so the first thing we need to do when placing a bomb is figure out which position to place it. We're going to instantiate our prefab here, or we're going to basically clone the prefab into a new game object. When we do that, we need to provide a position to instantiate the object at. So let's create a variable for position. It's just going to be the position of wherever the player is, which is this transform. But the player is not always going to be perfectly aligned to a grid while they're, running in between tiles. And so we can round these X and Y values just to make sure that when you place a bomb, it's always going to be perfectly aligned to our grid. And that's important. The way we set up our game with the way we kind of offset our stage and everything, our player, when they're at, oh, this is actually wrong. This should be -6. Oops, -6. So make sure these are all whole numbers. But yeah, you can see perfect whole numbers, we're aligned to our grid. If I go to 5, we're still perfectly aligned to our grid. 4, so that's where rounding is going to make sure all these numbers are whole numbers, which will make sure we're aligned to our grid. When we place down a bomb, it'll stay within one of those tile squares. So we're going to round both our X and our Y. The Z doesn't matter since this is a 2D game. And then we can instantiate our bomb. So we can say instantiate. We need to pass in the object we want to clone. So that's our prefab. We can provide that position, and the rotation doesn't matter. So we can say quaternion.identity is basically no rotation. And after instantiating the bomb, we need to reduce the amount of bombs we have remaining. So we can say bombs remaining minus minus. That's decrementing it by 1. And then this is where we want to suspend the execution of this function for a certain amount of time. We can say yield, return, new, wait for seconds. And we're going to wait for however long it takes our bomb to explode. So this is our fuse time here. Right, so this is going to suspend the execution of this function, in this case for 3 seconds, before we then continue on. And when we continue on, this is where we're going to handle the explosion logic, but we're going to handle that separately. I guess just for now, just for the sake of seeing that this works, we can just destroy the bomb. We'll just destroy the bomb afterwards, so we can see that this is working. Let's go ahead and try this out. We need to make sure we assign all of our variables here in our editor. So let's assign our prefab there. Input key is space. Fuse time, good. All that's good. I'm going to rearrange the order of these just so it's nice and organized. Okay, input key, bomb prefab, bomb fuse time, bomb amount. Let's go ahead and play. And we can drop a bomb. There we go. And after a few seconds, it'll disappear. And now the problem here is I can't drop another one, because my bombs remaining is 0, and we never set that back to 1 after the bomb is gone. So whenever we destroy the bomb, we can then re-increment our bombs remaining now that that bomb is gone. So we can then place another one. Run this again. We can drop our bomb. It's going to disappear. And then we can drop another one, and so on. Now, if I were to change... So let's say I changed how many bombs you have. Let's say you start with 2 bombs. Now I can place 1 and 2. And there we go. 1 and 2. Can't place the 3rd one. And so on. So that looks good. Beautiful. Hello, future Adam here. So I realized after finishing the tutorial that I missed one thing. So I'm going back and I'm interjecting this one clip into the middle of the tutorial, but you can see that I've already finished implementing the rest of the features. So ignore that all for just a moment, and let's just focus on this one thing that I missed. So when we drop a bomb, I can still walk over it and not able to push it like you're supposed to be able to do. So we need to add some additional logic to make it so the collision gets turned on after you walk off of it. You remember me earlier saying that the bomb collider is initially marked as a trigger, which is important because when you place the bomb, you're going to be standing on top of it, and if it's not a trigger, it's going to push you really weird. So we need to initially mark this as a trigger, but we never set this to not be a trigger after we spawn the bomb. Let's go ahead and open up our bomb controller. And we can add a function in here to handle setting that bomb back to not be a trigger when you walk off of it. So we can add a function called onTriggerExit2D. And once again, ignore some of this other code you're seeing. We will get to that in the future sections of this video. I'm once again interjecting this clip after the fact because I had forgotten about it. So onTriggerExit2D, Collider2D, other here. This is very similar to other functions that we commonly use, like onTrigger and enter. So this is where when you enter into a trigger zone, this is the opposite, where it's when you exit a trigger zone. So if our bomb is the trigger, when you exit that collider, when you walk off of it, then we can tell that trigger, that bomb, to no longer be a trigger and to be a real collider. So there's full physics interactions and everything. So here we can check if other dot game object, and we'll check the layer. So other dot game object dot layer equals layer mask name to layer. And if it's the bomb, so if the game object that we're exiting, if the layer of that game object is bomb, then we know we've just walked off of a bomb, and therefore we can set that collider for our bomb here to not be a trigger. So we can say is trigger is false. And that's all we need. This is all that I missed earlier. So we're adding in this one function. Ignore everything else. All you need is this one function. The only other thing that needs to be done is to simply go to our bomb prefab and set the layer to be bomb. Now, in some of the other clips of the tutorial, I already added these layers, but go to add layer. You can add one for bomb and then simply reselect your bomb and choose that layer that you added. It should match the name in the code exactly as we just wrote it. So make sure same casing, there's no extra spaces or anything. It should match that same name here. So now let's go ahead and try this again. Actually, let me turn off the destructibles here so we have more space to run around. So when I drop a bomb, now you can see I can push it. So initially I can stand on it because it's a trigger. It's a trigger, and it's not until I walk off. And then if I collide with it, now it's no longer a trigger. It's a normal colliding object with full physics interactions. And this is cool because now I can push the bombs, which is what you're supposed to be able to do in the real game too. You can actually take a bomb and push it. So it adds a whole nother kind of element to the gameplay where you can kind of push bombs. It adds a lot more strategy and everything. So it's really cool. It adds makes the game a lot more fun. And I can go ahead and I can push a bomb into the other player here, and so on. And so once again, I know at the current moment, the other player doesn't exist for you. So continue watching in the tutorial and we'll show you exactly how to implement the remaining features of the game. All right, now let's implement explosions to tie into our bombs. So we're going to set up a prefab for this as well, because whenever the bomb explodes, we will then instantiate an explosion object. So we need a prefab just like we did for our bomb. Go ahead and create that. Let's right click on our hierarchy, create empty. I'm going to call this explosion. I'm going to reset the transform. And let's go ahead and take a look at what we need here. So for components, we need a collider. For the collider in this, I'm going to make it be a box collider this time. Box collider 2D. It will be a trigger, because the explosion is not going to physically stop you from running into it. We actually want to allow the player to run into the explosion, because that's what then is going to trigger them dying. So we'll mark that as a trigger. And in my purposes, I want to actually reduce the size of the collider here. It's maybe hard to see, but you can see the green outline here. So the explosion would be taking up that full tile, just the collision area. Visually, it'll obviously take up the full area, but the collider, we don't want to take up the full area, because then if you just barely touch it, you're gonna die. I actually want to reduce this maybe to like 0.25. That way, if the player just like sort of scrapes the edge of it, they're not gonna just accidentally die. They have to like really step into that tile for them to hit the trigger and then die. I'm gonna reduce that, and that's good to go. Now, as a child of our explosion, we're going to do something very similar to what we did for the player, where there's 3 different sprites for the explosion. There's sort of the center one, or the starting one. Then the explosion can spread out. So there's maybe a set of middle sprites, and then this explosion has like an ending sprite. It kind of caps it off. There's kind of 3 different ones. So we're going to set it up just like we did for the player. We're going to set up 3 different children here. I'm going to right click, create empty. Also do this start. And we're going to add a sprite renderer. And we're going to add an animated sprite renderer. Same component that we've been using for everything. So for this one, we're going to set the sprite initially to 0, idle sprite to 0. And in this case, there's 8. Yeah, there's 8 different sprites. So let's set the array to 8. We can drag all of these in here. 2, 3, 4, 5, 6, and 7. 0 through 7. The animation time, since there's 8 of them, we can do 1 divided by 8. It should be looping, and it does not need to be idle initially because as soon as it spawns, it's going to start animating. So that looks good. I am going to disable these initially because the code has to determine which of the 3 is at start, middle, or end to enable, depending on where it's positioned. So we're going to have everything disabled and we will turn those on in our code. I'm going to duplicate this. I'm going to call this one middle, and we can just swap out some of these sprites here. So we'll swap that out and we'll assign all of these 0, 1, 2, 3, 4, 5, 6, and 7. So that looks good. Let's duplicate this one more time and set this to be end. And same thing. Let's add in these sprites here. Sprite render, idle sprite, and all of our animation sprites. 2, 3, 4, 5, 6, and 7. There we go. That looks good. So we've got our explosion with 3 different sprite renderers on it, depending on which of the ones we need to render. That all looks good. And let's see, do we need anything else? I think that's it for now. So we can drag this into our prefabs folder. And now we have a prefab for this. We can delete this now. We actually do need a script for the explosion itself to manage a few different things. I guess we don't necessarily need one, but it'll just make something simpler. Let's go ahead and create a new script called explosion. And actually, we will add this script to our prefab. So let's select our prefab and let's drag this script onto it there. And let's go ahead and begin editing this. Oh yeah, because our explosion script here needs to get a reference to each of those animated sprite renders. So for start, just like we did for the player, how we have references to each of those. That way we can enable them as needed. Start, middle, and end. Perfect. Oops, forgot the semicolon there. And let's see, what else do we need? The rest of the logic, there's not going to be necessarily a ton of logic in this script. Most of it's going to still be handled in the bomb controller, but we can add a few different helper functions in here. So let's add a public function called setActiveRenderer. And we're going to once again pass in the renderer we want to render. Just like we did for our movement controller, where we sort of passed in which of the renderers do you want when you're setting the direction. We can specify which of these 3 do we want to enable. And so here I can say start.enabled equals render equals start. Middle enabled equals render is middle. So whichever, if you pass in start, that will get enabled. Otherwise, it'll get disabled, and so on. So depending on which one you pass in, that will get assigned, or get enabled, I should say. Let's see, what else? So that, I guess that's it. All we need for that one. Just a little tiny helper function. We'll add another helper function for setting the direction. This is going to rotate the sprite to face the direction. You can see for these images I chose not to have, I could have had different sprites for each direction, kind of like I did for the player, but I found it to be easier to just simply rotate this instead. You can see all of these are always pointing in one direction. It really only takes 2 lines of code to just rotate it based on the direction, so it was a lot easier to do that. We can't do that for the player because it's just a completely different perspective, but since the explosion is just top down, we can just rotate it and it doesn't make a difference visually. So to calculate the rotation, we need an angle, And this is just a simple kind of like trig function. You can say math f.atan2. So it's getting the tangent or the arc tangent. And we need to pass in our y and our x. So this is just direction y and direction x. And so that's the angle of our direction vector here. And then from that angle, we can calculate a rotation. So transform that rotation equals, rotations are as expressed as quaternions, which is like a kind of complicated thing, math concept that I'm not going to get into, but quaternion, that angle axis is going to rotate some angle around some axis. So the angles, well, the angle we just calculated, and the axis is going to be our forward axis, which is our z axis. So for example, if I were to move our, let's just do our player. If I were to change the z axis here, you can see that's kind of rotating it. All right, so the explosion will face, it'll face whichever direction you are facing. So that's where we want to use the z axis to rotate it. The z axis is forward, 0, 0, 1 in the z. And that's it. So that'll rotate our explosion sprite to face the whichever direction we tell it to. And then finally, let's add one other helper function, which is to destroy the game object after a certain amount of time. So we can say destroy after. Actually, we don't even really need this. Yeah, actually, we don't need that. Never mind. We can get rid of that. All right, so we got a couple helper functions. We got our explosion, our references to our sprite renders. We do need to establish those on our prefab. So we got our explosion prefab. We still need to assign these. Let's go ahead and open this up and let's assign each of these start, middle, and end. There we go. All right, let's go back to our bomb controller and we can finish implementing our place bomb. So here, after we wait for the fuse, so the bomb is now actually exploding, we need to instantiate our explosion prefab that we just created. Let's create a new set of variables here. I'm going to get a reference to an explosion prefab. And here I'm going to type this as explosion, which means when we assign the prefab in the editor, whatever game object we pass in as our prefab must contain this script on it. All right, so we've got our prefab. We should specify how long does the explosion last for. So let's say it lasts by default for 1 second. And also how big is the explosion? Like what's the radius of our explosion? How many tiles does it spread out? And but initially it'll just be one. So it'll spread out in one tile every direction. And this is where we're going to have another power up or item pickup to change this. So this will become 2 and 3 and 4. And so it'll make your bombs even bigger. They'll explode in a bigger radius. All right, so that's good for now. Now at this point, we're starting to get a lot of variables on our script. And if we take a look at our bomb controller, you can see, there's just a lot of things on here. Something simple we can do to just further organize this. There's an attribute in Unity called header. So you put square brackets and then header, and then we can provide a name here. So we can say like explosion, and then same thing up here. We can say, let's say bomb. And what this will do is in the editor, you don't need to do this. It's not necessary at all. But you can see it creates these little labels in the editor just so we can kind of organize our different groups of variables. While we're at it, let's go ahead and assign our explosion prefab there. So that's good. Let's go back to our bomb controller. All right, so we waited for the fuse to go off. Our bomb now needs to actually explode. So we need to instantiate our explosion game object at the position of the bomb. Now, you can actually push bombs around. Like if the player walks into a bomb, it can push the bomb. So we need to reset the position to be now whatever the current position of the bomb is. Just in case that position may have changed since it was first instantiated. Once again, if you push the bomb, the position might vary. So we're going to reset our position here and we're going to re-round all of these values to make sure that our explosion also perfectly aligns to the grid. Position Y. Perfect. All right. And so now we can instantiate our explosion. Equals instantiate. We'll pass in our explosion prefab. And because we specify that our explosion prefab is an type explosion, our instantiate function is going to return us explosion rather than just game object, which is nice because then we can access some of these functions and things on it. We're going to instantiate our prefab at that position, and once again we don't care about rotation, so we'll just set that to be identity. Well, we actually do care about rotation, but we're going to call that helper function to do that. So all right, on our explosion we're going to set the active renderer. This very first one is always going to be the start one, so this will always be the start. Essentially, maybe what I didn't make clear is that these explosions are representing a single tile. So when a bomb actually explodes, it's going to instantiate a bunch of explosion game objects for each tile. And so initially we spawn one where the bomb is, and that's going to be, the start. And then we go instantiate more. That will be, we'll instantiate some middle ones, and then we'll instantiate an end one. And that's going to be, there's going to be a little bit more complicated logic there. And then before we get into that, we need to just do one other thing, which is we need to destroy our explosion game object after X amount of seconds. So that's our explosion duration. So it'll destroy that game object after so long. All right, this is where we get into a little bit more complicated logic, where this is just spawning. Let's test this out before we get into it, just to see. So let's go ahead and play. We're gonna drop a bomb. Explodes. There we go. So we can see just that on that one tile, it spawned the explosion. It's animated, but we need to actually make it explode in a radius now. So that's all that's missing. So let's add a new function called explode, and we're going to explode at some position in some direction. Oops. So we'll have the position and then a direction we're exploding in, and then finally, what is the length of the explosion. And so essentially what we're going to do is we're going to call this for every direction. So we're going to explode up, and the length will initially just be the explosion radius. And then we're going to explode down, left, and right. So explode down, explode left, explode right. So we're going to explode. So we spawn the center piece, that kind of the starting piece right in the center. And then we're going to explode up, down, left, and right as needed. So here and this is going to actually be a recursive function, because it needs to then, that's going to explode one tile up, one tile down, one tile left, one tile right. But then if your explosion radius is even longer, well, then it's going to call explode again, and it's going to then go to the next tile to the left, the next tile to the left, and it's going to keep going until this length hits 0. So when you define a recursive function, you need some kind of exit condition. Otherwise, this function is just going to get called over and over and over again. So once our length hits 0 or less than or equal to 0, we return. We stop exploding. Now, when we explode, we need to get the new position of the explosion. So that's going to be position plus direction. So we can just say position plus equals direction. So that's going to be the new position we're exploding the bomb at. And we can instantiate a new explosion at this position. So we can just copy this line of code up here, copy all that's exactly the same. But now it's not always going to be the start. This will either be the middle or the end, depending on the length. So if the length is greater than 1, we're still in the middle of the explosion. So we're going to say explosion.middle. Otherwise, will be explosion.end. So once the length, once there was only one length left, you know, one tile left, then you're at the very end of the explosion. This here is called a ternary statement. It's kind of like writing an if statement where there's some condition. If this condition is true, it returns this. And if the condition is false, it returns this. So once again, if there's still multiple lengths left, we're still in the middle of the explosion. Otherwise, we're at the end. All right. We can also set the direction here. The direction is just the direction we passed in. We didn't need to call this for this one up here because the direction, there is no direction really. It's just the kind of the very center of the explosion. So there's no direction. But for these now, you're exploded in a particular direction. So once again, this is going to rotate it so it faces that direction, depending on if you're going up, down, left, or right. And then, yeah, and then we destroy this explosion after the duration. And this is where the function is recursive, that we're going to then call explode again. Same position, or well, this new position, same direction, but now the length is reduced by 1, right? And so this is where it's going to recursively keep exploding, exploding, and exploding until eventually the length hits 0. Then it's done. It can't go any further, so it'll stop. It'll hit this exit condition and return and won't proceed forward. Let's go ahead and test this out. You know what, just for the clarity in the code, I am going to add this helper function here to our explosion script. I'm going to say public void destroy after seconds, and we can just say destroy game object after seconds. I just personally find that to be a little bit cleaner in our code, so we can say explosion.destroy after the duration. Just, in my opinion, makes the code a little bit cleaner to read. Same thing, explosion, destroy after so long. You don't have to do that, but makes the code a little bit cleaner in my opinion. All right, let's test this out. This isn't fully finished, but it's almost there. So we can drop a bomb. Explodes. Now it looks like there's some problems, so I paused the game. But it looks like there's some issues. So for one, it looks like we have all of our sprites in place. Oops. We have one in the middle. We've got one there, one to the left. And so these ones are being hidden behind our bricks. So we need to, let's fix that real quick because that's an easy fix. Go to our explosion. On these 3 sprite renderers, we need to change the order in the layer. These should be 4, so our bomb was 3, so these will be 4. That way they get shown on top of the bombs. So we'll set start, middle, and end to 4. Let's test this again. Drop a bomb. We'll pause it right when it explodes. Okay, so there we go. It's running on top, but the rotation is definitely not correct. So that's an issue we need to fix. But otherwise, that's working in terms of it going in each direction. Let's take a look at our rotation function. I believe I actually know what the problem is. Yeah, so our tangent function returns an angle in radians, whereas this function needs an angle in degrees. So we need to say angle times mathf radians 2 degrees, rad 2 degrees, to just make that conversion there. That'll fix our rotation. All right, I hope it does. Let's throw another bomb. There we go. So that looks perfect. So it goes in all its direction. It's rotated properly, and it goes in 1. So now, like, if I change, let's say I change my explosion radius to 2, we can drop a bomb, and it should go even further now. Yep. So there, it extends it in 2 in each direction now. That's really nice. So that is kind of the power of our recursive function, where we're going to explode in each direction, and it's going to keep exploding in that direction over and over again until eventually the length hits 0. So that's where every time we recursively call this, we reduce it by 1. So it'll just keep going in that direction until the length is 0. Now, the only thing missing, as you maybe noticed, is that our explosion goes out of bounds. Essentially, it needs to stop when it hits a tile that is taken. it should only explode on the available tiles. Otherwise, it'll stop. Let's go ahead and add that. And then that is it for our explosions. All right. So what we need is a way of detecting which tiles have colliders on them. We can check, hey, does the tile at this position have a collider on it? If it does, we will stop there. We won't continue the explosion in that direction. So keep exploding in the direction so long as there's no collider in its way. We can do that by, oops, let's go to our bomb controller. So before we actually instantiate our explosion, we need to check that this position is available, essentially, that this position is not taken by some collider. And we can do this with a built-in function called physics, if physics2d.overlapBox. So we're essentially checking, is there a, this is going to return a collider that's overlapping at some points. We're essentially forming a box. We're seeing if there's a collider overlapping that box, some point size, so on. The point is the position. The size doesn't really matter. We can just do 1, but I'm going to actually divide it by 2 just to make sure that it's not covering, it doesn't touch multiple tiles. So I'm just going to divide it by 2 just so I guarantee that it's just within one tile. The angle doesn't matter because we're not rotating the box in any way. And then we do need a layer mask. What this does is it's going to check only certain layers for objects. So we only want to check like the stage itself. We don't want it to stop if there's other bombs or other explosions or the players. We only want it to stop if it hits some of these stage objects. So we need a layer mask, which means we need to add a new variable here. I'm going to add a layer mask for, we'll call this explosion mask, or we'll just call it explosion layer mask. And we can pass that in as our last parameter there, or argument there. All right, and this, once again, this returns a collider. So if it returns a collider, then, well, we know that we hit the edge and we don't want to explode. So we can return so it doesn't instantiate an explosion because we've hit essentially a different exit condition to say, well, we hit the wall, we don't need to do anything else. Otherwise, if this doesn't return a collider, that means that tile is completely open. There's nothing blocking the path, and so we do want to then continue on and let it explode. And once again, this is going to happen recursively, so then as it goes to the next tile, it's going to check again, hey, is this one available, and so on. All right, all we need to do is set our explosion layer mask, but we haven't added any layers yet. So we can go ahead, let's go to our stage here. We can go to the layer property at the top, we can add a layer, and we can add a layer for our stage. And now we can go back and we can set that. And it's going to ask us, do we want to change all the children? And yes, I do. I want to make sure that both the indestructible and destructibles are set to be the layer stage. So now on our bomb controller for our explosion layer mask, we only want to look for stage. We only want to check to see that's colliding with the stage and nothing else. Now, if I place a bomb, it should stop. Yeah, so notice here, it didn't go up, it didn't go right, and it didn't go down because it's hitting those colliders. Whereas it does go left because it's not hitting anything. That works perfectly. All right, let me place one more right here, and we should be able to see that it goes both right and left, but not up and down. Yeah, so perfect. So it goes up, or it doesn't go up, it doesn't go left, it does go down, it does go right. It goes right too, even though I'm standing there, because we're not looking for my collider because we didn't select it here. We only selected it to look on the stage. That's good. And let me reset our radius to 1 by default. So that is it for now in terms of explosions. I know that was quite a lot. It's definitely the most complicated part of the tutorial, but that is a major component done now. All right, so the next step is to make it so we can actually destroy these bricks whenever an explosion hits it. And so what we're going to do for this, these bricks are just part of our tile map. So we need a way to be able to clear the tile from the tile map so it doesn't render. But I also want to animate that brick going away. So what we're going to do is we're actually going to instantiate a new object at that exact position of the tile, which will be animated. And then we'll clear the tile map as well. And so it'll sort of just replace the tile map tile with just some game object that's sitting on top of it that's animated. And then once that animation finishes, then, you know, then the whole thing is gone. And now that spot is available. So just like we did for our bomb and explosion, let's create a new prefab to represent one of these sort of animated destructible bricks. So let's create a new empty game object. I'm going to call this maybe destructible. Sure. We'll reset the transform. And this needs a sprite renderer. And we can assign our brick destroy here. So we can assign this as our initial sprite. Or actually for the initial sprite, it should just be the regular brick. Just because we're going to instantiate a copy of this on top. So we want to just kind of mimic it exactly. So it'll just be the normal brick initially. And we need to set the order and layer for these as well. So if our indestructible is 0, Destructibles is 1. We want to make sure this is sitting on top, so these should probably be 2. Because yeah, then our bomb is 3, our explosions are 4, and our player is 5. So everything perfectly lines up in that regard. So let's set this to 3. All right. What else? We need a collider. Back to collider 2D, because I don't want the player to be able to walk over it until it is fully exploded and gone. So we're going to have a collider to prevent the player from walking on it until it's completely gone. Size and everything can be exactly the same. It's not a trigger. We actually want the player to be stopped by the collision. This, of course, will be an animated object. We can add our animated sprite renderer. Let's assign these different things. So our idle sprite is just a regular brick. And then for the animation sprites, we have these, 7? Yeah, 7 sprites here. We can assign all of these 0, 1, 2, 3, 4, 5, and 6. And you can see 6 is an empty one, so it'll kind of animate through and then it'll stop and just a completely empty sprite, so you won't see it. This we can say there's I'm gonna do 6 frames a second. 1 divided by 6 frames a second. It should not loop and it should not be idle. We don't want it to loop because it needs to go through and then stop. We don't need it to be idle because as soon as it instantiates, it's going to start animating. And that's good there. And then finally, we can have a script for this object as well. So we can create a new script and we'll call this Destructible. And we can add this script to our object here, drag it to the empty space. And now let's turn this into a prefab. So we can drag this into our prefabs folder and we've got our beautiful little prefab. And we can then delete it from our scene. All right, so when, let's see here. So when we explode, or yeah, where should we do this? On our bomb controller, go to our bomb controller. We need to get a reference to that destructible prefab. So I'm going to kind of create a new section of variables here. We'll call these destructible. And I need to get a reference to that destructible prefab. So destructible prefab. And I also need a reference to the tile map itself so I can clear the tile on it. So we can get a reference to our tile map. And to get a reference to the tile map, I need to import using Unity engine.tilemaps. So we can call this the destructible tile. Yeah, destructible tiles. We'll just call it that. So we got the tile map, and then we got the prefab that we're going to instantiate on top of our tile map, and then animate that object kind of getting deleted or getting destroyed. Let's see. So here, when we see that we hit some kind of collider, So we explode, we see, hey, at that explosion position, is there a collider there? If there is, well, that's potentially a brick, which therefore should then be destroyed. So instead of just returning, we're going to do something else first. We're going to actually call some other code in here. Let's add a new function and maybe call this like clear destructible and add some position here. So we're going to clear the tile, the destructible tile at that position, right? We have a tile map called Destructibles, which are all of our bricks. We're going to clear the one at that position. So let's go ahead and call this function here when we've detected that we've hit one of the stage tiles. And in here, we can get we need to actually get the cell from our tile map itself. So we can just say vector, the tile map stores everything as vector3 ints. We'll call this a cell. We'll say destructible tiles dot world to cell. So we need to convert a world position to a cell position. World cell at that position that we passed in. Then we can get the tile at that cell. So we'll do tile base tile equals destructible tiles dot get tile. So it's going to get the tile at this cell position. And this can either be null or not null. So we need to check, because it won't be null if we're only passing a reference to our bricks. So yeah, we haven't set that yet. So let's pass in our reference to our destructible tile map, and then let's also assign this prefab. So it's possible that there won't be a tile at that position, in which case it'll be null. And so we just want to add a check here that way we don't cause any errors when our game is running. And so if there is a tile there, it's not null, then we can instantiate that destructible prefab on top of it at that exact same position. And then we will clear, we will then, once we instantiate this new object on top of it, we will set that tile to be null. At that position, or at that cell position, we will set it to be null. So we're removing the tile from the tile map and replacing it with a new game object that's going to sit on top of it, that will be animated, and then that object will go away once it's finished animating. And yeah, actually, I think that's it. Just in our destructible script, we added this. We never did anything in it. This will be pretty simple. There's not much we need to do in this. Basically, we can add one variable for how long does it take for this object to get destroyed. So we can just call this like destruction time, and we'll just say it takes, let's say, 1 second. And then when our function starts, so in our start function, once again, this is a built-in Unity function that gets called the very first frame this script is enabled. We will destroy our game object after that destruction time. All right, and that's actually it. That's all we need. So once again, if we detect that our explosion hit a wall, essentially, we're going to clear the destructible at that position. So we look up the destructible tile, we convert that position to a cell, we look up the tile at that cell. If there is indeed a tile there, we will then clear it and instead instantiate our new object on top of it, which is basically just an object to run through the animation. Let's go ahead and test this out. We can drop a bomb. Boom. So you can see, I paused it again. You can see in our object, there's two destructible things that got cloned here. So we cloned that prefab, it spawned them on top of those tile positions. You see, if I remove these, there's nothing beneath them because we cleared the tile from the tile map itself and spawned these in place of them. And so these now will cycle through the animation, you know, and then as they go away, boom, once, you know, because of the code in our destructible script, it says destroy the game object after 1 second. you can see now in our hierarchy, all those game objects disappeared. And then we can walk in that space again. And now we can, you know, so we can go here and we can keep setting bombs and kind of destroy the tiles as needed. So there you go. So now we have destructible bricks. Great. All right, next we need to implement item pickups, which is going to tie really perfectly into the destructible bricks that we just implemented. Let's go ahead and first do a little bit of setup to create our different item pickup prefabs, and then we can implement the code. The code itself there won't really be that much to it. So it's mostly just the setup here that we need to do. Let's create an empty object. I'm going to call this item pickup. I'm going to reset the transform here. And let's add a sprite renderer. Let's add a box collider. 2D. And because I haven't assigned a sprite, the size just gets kind of set to 0. But so I can set this to 1. And we can see it in our scene here. And actually, I'm going to set the size to 0.5. This way, if you're kind of running right past, sometimes it might still trigger the collision if you're right on the edge there. So to make sure the player actually walks into that tile, I'm just going to reduce the size here to 1/2. I'm going to mark this as a trigger because you don't want to physically collide with it. You want to check that the player has collided with it, and that's going to trigger, you know, the item being picked up. So we don't want like physical collision with that object. And what else? We will need a script to actually handle the logic of what happens when you pick it up. And I think that's it. So let's go ahead and create a script for item pickup. Item pickup. And we can assign this here or drag that in there. And that's good for now. I guess I'll duplicate this a few times. So I have one for each. So I've for the tutorial, I have 3 different item pickups. You can definitely add more, and you can get really creative with whatever you want to do with them. But for demonstration purposes, I've got 3 different pickups. Let's actually do one for each. So we'll do blast radius, and we can assign that sprite here. And it's getting rendered behind, so I'm gonna set the order here to be 2. That way it renders on top of all the stage. We can duplicate this. We'll do another one for the extra bomb. We'll drag that sprite on there. We'll duplicate it one more time, and we'll do speed increase. And we'll drag that sprite on there. Beautiful. Okay, let's turn all of those into prefabs. And actually, I'm just going to call these simply item. Instead of pickup, item, blast radius, item, extra bomb, and item speed increase. Turn these into prefabs, drag them into my project panel, and then I can delete them from my scene. Let's go ahead and implement the logic for item pickup. So we need a way of actually determining which of those pickups it is. And something we can do in C# is to add an enum, which allows us to essentially have an enumerated list of names. We can have public enum, we'll call this item type. And here we can have, you know, extra bomb, blast radius, and speed increase. So you'll write the names, you'll separate them with commas, and then we can actually declare a variable for this item type. And so now notice in the editor, if we take a look at our script in the editor, so we select on any of our prefabs, you can see that type shows up, and I can then choose from a drop down of which one I want. For blast radius, I'm going to choose blast radius. For bomb, extra bomb, and for speed increase, we'll choose the speed increase. And so now we can implement some logic to say what happens, and we can do that logic depending on which of the types you've selected. To actually detect that a player has picked the item up, we can use a built-in Unity function called onTriggerEnter2D, and then this takes in a collider 2D that I usually call other. So it's the other collider that you've collided with. So in this case, what's the other collider colliding with the item? which would be the player, or we need to check that. So we can check, hey, is this other object the player? And we can do this in a couple ways. We can check the tag of the object. We can check the name of the object. We can check the layer of the object. It's usually not a good idea to check the name. We could set the layer, but we don't even have another layer for the player. So I think the easiest case for us is just check the tag of the game object. That is any game object that's tagged as player. Well, then they're the ones who are able to actually pick up the item. And now it's like, okay, well, what do you do when you pick up the item? Why don't we have a separate function to handle that? So we can say like on item pickup. And we can pass in the game object for the player who picked it up. So here we can call that function and we can pass in other.gameObjects. So that's referring to the player because we just verified that the game object is tagged as player. So pass that in. Now we can implement whatever logic we want to on item pickup. And we will switch on the item type. So switch statement is sort of just a different way of writing an if statement, or like an if, else if, etc. Here we can switch, and if the case is item type dot extra bomb, then we can do one set of logic, and then we break. Then we'll add another case to say if it's blast radius, then we'll do some logic and we'll break. And then if the item type is a speed increase, we'll do some logic and break. And that's it. And then once you pick up an item, we can destroy the item. So we can just destroy a game object. All right, so let's actually implement what happens when you do these. So there's really not much we need to do for, let's say, speed increase. We just need to get a reference to our movement controller and change the speed here. So we can say player.getComponent, movement controller, and we can say speed ++. So we'll increment the speed by 1. And then same thing, blast radius, we can say player.getComponent bomb controller, and we can say explosion radius ++. So we'll increment that by 1. And then for our bomb, basically same thing, player.getComponent bomb controller, and we can say bomb amount ++, but we actually need to do more than just that, because when we increase the amount of bombs, we also need to increase the amount of bombs remaining. So let's just add a simple little function in here to say add bomb. And we can say bomb amount ++ and bombs remaining ++. And so instead of doing that, we'll just call that function here. We're going to make sure that function is public, otherwise we can't call it from our other script. And so that's it. That's all we need for item pickups. It's actually pretty simple. Oh, we actually need to spawn the items though whenever a brick is destroyed. So we can go to our destructible script here and we can add in some new logic. So we can, let's say, add in some variables for like, what is the spawn chance of an item? You know, we say item spawn chance. Maybe initially this is like 20%. So that would be like 0.2 is saying with 20%. So there's a 20% chance that an item's going to spawn when you destroy one of these items or destroy one of the objects, so the bricks. And then when an item does spawn, well, what are the objects that can spawn? So we can get an array of spawnable items. And this will be those 3 prefabs we created. Now, something we can do for that spawn chance is, if we take a look at our destructible prefab here, where we have the destructible script, for the spawn chance, something we can do is use a range attribute, and we can specify a min and a max. So we can say between 0 and 1. This is going to make it so in the editor here is the slider. So we can make sure it stays within 0% and 100%. And I've got a nice little slider there, which is cool. For our spawnable items, let's add 3 of them, and we can drag in those 3 prefabs that we specified. Oops. So 3 spawnable items, it's those 3 items. And we're good there. And let's finish implementing this. So when our destructible object is destroyed, like when the entire game object is finally destroyed, so after, you know, however long the destruction time is, it's going to trigger a function called onDestroy. This is a built-in function that Unity calls automatically, so make sure the casing is exactly the same. It needs to be uppercase O and D, not lowercase, or it won't get called. And so when our game object gets destroyed, that's when we will spawn an item. So first, let's make sure that there is an item to spawn. So we got to make sure the length of this array is greater than 0. Otherwise, we'll get some errors. And we'll generate a random value. A random.value, or regenerate a random float between 0 and 1. If that is less than our spawn chance, well then we're good. We can then spawn an item. Otherwise, if it's greater than our spawn chance, then we don't spawn anything. Here we can then just get a random index in our array by saying random.range between 0 and then however many items there are. So spawnable items.length. It's going to get a random index in our array, and we can then instantiate that item. So spawnable items at that random index. We're going to spawn the item at the same exact position of this object, and rotation we don't care about, so we can set that to identity. And that is it. Alright, so let's test this out. Let me just double check this again. On our destructible, yeah, we got spawn chance is 20%. We got our 3 items. Feel free to customize this once again however you want. And let's go, just for the sake of testing, I'm just going to bump this up to 0.5 so I can quickly test this out. And let's verify. We want to make sure that these values change. Oh, also, I need to reset our bomb amount to 1 here. That should be the default. I guess it doesn't really matter, but all right, so explode. There we go. I got 1 of them here. So this is blast radius, so we should see this increase to 2 when I pick it up. Oh, I guess nothing's happening. We're not picking it up, and that's because I never set our player. So we remember in our item pickup, we said if the other object is tagged as player, then we will pick it up. I never did that. I never set our player here to be tagged to player. We can set the tag to player, and now we should be able to pick up our items. Let's destroy this again. All right, so I got an extra bomb, so we should see bomb amount go to 2. There it goes, went to 2, and now of course I should be able to drop 2 bombs, which I can. Let's get some others. Okay, I got another one, so we'll get 3 bombs. That'll just make it easier to test. We'll get 3 bombs here. Here we go. I got a blast radius. We got a speed increase. So speed increase, go from 5 to 6. There we go. And I am faster. Got 2 blast radius, so we should see that go to 1, then to 2, then to 3. And now, of course, my blast radius should be much bigger, which it is. We haven't implemented death, by the way, so I can just kind of freely walk over that, but that will come soon. And yeah, I can just start implementing all these. Boom. So now I'm getting all these power-ups. Lovely. Speed. Yep. Move much faster. So power-ups, items, all working perfectly. Very simple to implement too. And now I can actually just kind of have fun, like going around and exploding everything. Got all these bombs. And you can see just the radius is getting bigger and bigger. I'm going to drop more and more bombs. My speed here. Super speedy. Nice. So super fun. Love it. Okay, cool. That's good. We're all good there. All right, next up, let's implement the death sequence for our players who actually die when you run into an explosion. So let's go ahead and go to our movement controller. And we're going to add some new functions in here to determine when you die. So just like we did for item pickup, we need the on trigger enter. You know what, might as well just copy this, add this in here. And so when the player triggers or collides with an explosion, then we need to trigger the death sequence. So we can say if the other object you're colliding with, now we could do a compare tag again. We could do that, or we could do a layer, it doesn't matter. I think in this case, I'm going to just do the layer, just to show you the difference between doing compare tag versus doing layer. Doesn't necessarily matter. But if we wanted to compare the layer of the object, we can say other game object layer equals layer mask name to layer. And then we can say, let's say explosion, for example. Then in that case, we know we triggered or collided with the explosion, so we can trigger a death sequence. So why don't we have a function called death sequence? Death sequence. And we can call that function here. Beautiful. So when the player dies, we need to disable all of their behaviors. They shouldn't be able to move. They shouldn't be able to do anything. So we can disable, since we're in our movement controller, we can just say enable this false. That'll disable our movement controller. We should also disable our bomb controller, but we need to get a reference to it. So we can say get component bomb controller is also disabled. Then we need to disable all of these sprites, and we're actually going to add another one specifically for our death. So let's disable all of these. Sprite render down, disabled, sprite render left and right. Okay. And then we need to add a new one, which we'll have to set up in our editor. But we're going to add a new one for oops, typo there. We'll add a new one called sprite render death. And this one will get enabled when we die, of course. And then finally, you know, after this animation finishes, we should completely turn off our game object for the player. So we can say, like, we can invoke a function here after some amount of time goes by. The time just essentially being how long we want to wait for the animation to finish. Let's do on death sequence ended. That'll be the function we invoke. So invoke name of on death sequence ended, and we'll just hard code this to like 1.25 seconds. I think the animation will take 1 second, and then I'll just add a little buffer of 1/4 just to make it a little bit smoother, but it doesn't really matter. So when the death sequence is finally over, we're going to completely disable this game object. So we can say game object set active to false. That'll completely prevent the entire object from rendering, no collisions, no physics, no behavior, nothing about the object will be active. And then there'll be some more things we do with like determining if there's a winner. You know, if there's only one player left, then you're good. But for now, that's good. Let's go ahead and actually set up this new sprite renderer on our player here. So we can add a new one. Let's actually just duplicate one of these existing ones. I'm going to call this death. And we can change the sprites on here to be player white death here. Let's set the idle. Let me pull up my other thing just to make sure I'm getting this right. Cool, yeah. So we've got our first script here. That'll be our initial sprites. Same thing for idle. I guess we don't really need an idle per se, but there's say 6 animation sprites. So we'll drag all those in. Death 0, 1, 2, 3, 4, and 5. Yep, this is good. 1 divided by 6. It is not looping and is not idle. As soon as this gets enabled, we want it to play. But initially, these will be disabled. We want to make sure these are initially disabled. But all is good there. Make sure our order in layer is set, just like the others. And since we duplicated it, already was. So that's good. So that's all good. We can then assign the reference to this new one in our controller here. And I think that might be it. Oh, we need to set, so in the code, we're checking the layer of the explosion. So we didn't actually change the layer yet. So we can do that here. And why don't we go ahead and add layers for everything while we're at it? So we can say, let's add a layer for the player. Let's add a layer for, We have stage. We can do bomb, explosion, and maybe item. And so we can set all of these. So on our player, we're going to change the layer to player. Yes, we'll also change all the children. For our 3 items here, we'll change these to item. For our explosion, we'll change it to explosion. Yes, change all the children. Destructible is part of our stage, so we'll set that to stage. Our bomb is bomb. So let's go ahead and play. Let's test this out. So we should be able to die if we actually hit this. Yep, so I ran into it and I died. I played the animation and then I just completely disappeared because I'm turning off the game object afterwards. And now at this point I can't do anything, which is, I guess, intended. But let's try that one more time. This time I'm just going to stand right next to it. Yep, there we go. I die, play the animation, I go away. I can't do anything, obviously, so that's all working. That's good. All right, the final thing really is to add a second player and then determine if there's a winner if there's only one player remaining alive. So we can just simply duplicate this object entirely. We'll call this one player 2. We'll rename the first one to player 1. I'm going to spawn player 2 in the opposite corner. So we'll bring him all the way down to the bottom here. Make sure these are nice whole numbers. We'll do 6 and -5. Oops, -5. Now we can go into all of these and replace the sprites with a different variant. So we can go to the up here. This is a little tedious, but it only needs to be done once. But we can reset all of these. So on the up, we'll do 0, 0, 0, 1, 2, and 3. Go to down, 4, 4, 4, 5, 6, and 7. So I'm replacing white with black. For 8, we need, this is left. Oops, oh, I screwed up. Let's go back to black here. Okay, so left. 8, 9, 10, and 11. Let's go to right. Almost done. 12. Oh, that's the wrong one. 12. Nope, that's also the wrong one. This one. There we go. 12, 12, 12, 13, 14, 15. And the death sequence is its own asset here. So we'll do 0, 0, 0, 1, 2, 3, 4, 5. So a little tedious, but that's okay. It only needs to be done once. And obviously you can add more than 2 players. You can add player 3, player 4, and I have, variants for red and blue as well. So you do that same process, duplicate it, change the name, and just replace the sprites with the different variant. Set wherever you want them to spawn. And this is where I should change their inputs too, because otherwise I'd be controlling both at the same time. I can kind of, since they have the same inputs, I'm controlling both at the same time. So I can change, let's say player 2 will use arrow keys. So we do up arrow, down arrow, left arrow, and right arrow. And maybe for bomb, they press, maybe for player 1, they do right shift. Where is this at? We'll do right shift. Somewhere in here. They'll do right shift, and then maybe for player 1 I could have done left shift, but for the sake of time I'll keep it. But yeah, feel free to use whatever inputs you want. All right, so I think that's it. Player 1, player 2. So now I have 2 separate players. So now you and your friends can play together. Obviously, it's just local multiplayer, so you have to be playing on the same computer. But now I can control both of these separately, and I can play against my friends. I was playing with one of my friends with earlier, and it was actually a ton of fun. Just having 2 players, it's a ton of fun. And you can really customize like the kinds of game modes and stuff by like you can just play around with all the different variables. Like maybe you maybe both you and your friends start with 20 bombs, or maybe you start with the explosion radius is huge, or maybe you start where your movement speed is really fast, and like you can just fully customize and kind of create different game modes and just really have fun with your friends if you're together in person. It's super fun. You can change the, the drop rate of items, so which I never did. I think right now it's still set to every 50%, which is quite a lot. But yeah, you can just make it so there's like tons and tons of item pickups. You're just getting super powerful, and yeah, you can just have a lot of fun with it and customize it how you want. All that's missing is that we detect when a player essentially wins. And a player wins when they're the only player left alive. Let's just quickly do that. There's not much we need for this. I'm going to create a new script called Game Manager. And I'm only going to do a little bit here. I'm not going to really keep track of like score and things like that. I'm just going to simply check, hey, is the player the last one alive? So I can go in here in our Game Manager. We can get in a reference to our players here. So we can get a public array of game objects. We'll call this players. Then we'll simply add a function to check the win state. And we determine if a player is won depending on how many players are alive. And we know if a player is alive if the game object is still active, because when they die, we turn it to not be active. So let's get a variable here to say alive count initially is 0. We're going to assume everyone's dead. We're going to loop through each game object, so each player in our list of players. If that player is alive, so we say active self, this is checking if that game object itself is active. Well, then we know the alive count is, incremented by 1. And so after it loops through, it's counting how many of the players are still active. That will determine how many players are alive. And here we can check if our alive count is less than or equal to 1, then the game is over. Someone's won. So we can then maybe invoke a function. Let's say we have a function called new round. And we can invoke new round here. Invoke name of new round. Let's say there's a 3-second kind of intermission between starting a new round. To start a new round, we can just reload the scene. It'll just kind of restart everything from scratch again. To do that, I need to import using Unity Engine. That's scene management. And then I can simply say scene manager load scene. And I can just load the scene I'm currently on. I'm just going to reload it. So we need to load by the name. We need to load either by name or build index. So I can say scene manager dot get active scene dot build index. Or actually, is there a get active scene dot build index, and that's it. It's just getting the current scene, getting the build index of it, and just reloading that. Then we just need to call our check win state. So when a player dies here, we just call that, so we can get a reference to our game manager. We can find it in our scene and then call a check win state. Because now that we're setting one to be deactivated, when we call this again, this value or the alive count is going to be different. And assuming there's only one or no players alive, maybe 2 players die at the same time, it'll start a new round. So, and we just need to make sure we add our game manager to our scene. So I'm just going to create an empty object, reset this. I'll just call this game manager. It doesn't really matter though. We'll throw our script onto it. And then here's our list of players. So we can set this to 2. Obviously, if you have more than 2 players, make sure you to change that. Drag our references there and we're good to go. Cool. Let me, just for the sake of testing, I'm just going to disable all the Destructibles so I can just verify that this is working. So we're going to run down here and we will kill the other player here. Oh, we never did. Okay, we got to do one more thing. Let's kill the player there. If that player dies, there's a little intermission and then the game resets. Perfect. So I'm not worrying about keeping track of score and stuff. You feel free to implement that yourself if you want, but this is just kind of a local multiplayer game. If you're playing locally with one of your friends, just keep track of score yourselves. Like, it's just, I don't know, in my opinion, just easier that way. But this is good. Potentially we can both die and it should still reset. Yep, there we go. Nice. So just a few closing thoughts to wrap up here. So this is a perfect game where you can really customize so many different aspects about the game. You can see here, in this case, I added 2 other players, so I can have a 4-player local multiplayer. Each player has their own, you know, unique set of controls and so on. It's really fun. You can really get creative with, you know, the different kind of game modes you can create in a sense by changing some of these default settings, how many bombs you have, how big are the explosions, how fast do the players move. You can obviously customize the stages as much as you want. You can create new stages. You can really do so many different things to make the game unique and fun, and just play around and see what works. Get a friend to play the game with, and you know, see what you can come up with. And I would love to see anything you create. I really appreciate you watching this tutorial, and I hope you learned a thing or two along the way. Give the video a thumbs up or down to let me know how I did. Subscribe to the channel for more videos just like this one, and leave a comment recommending what you would like to see next. If you want to support my work even more, you can become a Patreon member to receive exclusive benefits, including access to the Unity assets that I develop. Link in the description of the video. Thank you for watching. See you in the next one.